Hmm. All right, welcome back to our programming concept series. And in this video, we are going back to explore design patterns and we will explore the decorator pattern, a powerful structural design pattern that lets us add behavior to objects dynamically without changing their classes. So, the objective of this definition, object in definition, the goal of the decorator pattern is to extend an object functionality at runtime by wrapping it with another object that has the same interface. Each decorator forwards calls to wrapped component and adds extra behavior before, after, or even around the call. So why use it? Why we use this? Because inheritance can lead to subclass explosion. For example, if you want an email notifier and then add an SMS and then add a Slack, you could end up with classes like email notifier with SMS and Slack and push. It's infinite, go beyond and above. Decorators solve this by stacking responsibilities at runtime, and it follows the open-close principle. Open for extension and close it for modification. So let's talk about some analogy here. Think of a cup of coffee. The coffee itself is the base object. When you add milk, caramel, or whipped cream, or you are decorating the coffee, it's still coffee, but with extra behavior. That's exactly what this pattern does. Let's see some didactic notifier here, a didactic sample. So first of all, we need to create our notifier here. So it's just an interface, a notifier with send a message. It's pretty simple. Then we need to create the base, the coffee. The base is the mail notifier. So the mail notifier is from notifier and is just sending. So we are implement this send and create the coffee, the mail notifier. So what this does is just sending an email with the message. Pretty simple. This is the core implementation of an email notifier. Now let's talk about the base decorator. Now we create an abstract base decorator and it implements the same interface and holds a reference to another notifier. So we have the notifier decorator here is an abstract notifier. Uh, it comes from iNotifier and it's a notifier decorator. So we can receive another notifier that I don't know which one it is, and I just send the same. So I need to create some other concrete classes. So let's see an SMS decorator here. So now it stands for notifier decorator, and we have this constructor here that we receive a notifier, the base notifier, and we override the send. So the base send the same thing, and now we are sending an SMS notification, and we can do some more. We can run some more. Slack notifier. It comes from notifier decorator. So I'm doing the same thing here, and I'm overriding this send. Now I have the Slack notification. So use it. Now, let's see this in action. We can come here in program and we create an email notifier, then wrap it with SMS notifier, and then wrap it with a Slack notifier, Can you see? So here we have the base. And now we can add in some other notifiers. And then we will just send the message. The message is system out. Can you see? I'm just sending one message here. But now we have all of this rapid. This is the base, and this is rapid. So let's see the output here. So we have an email notification, an SMS notification, and a Slack notification. So we dynamically stacked behavior without creating new subclasses. We have just stacked some new behaviors, some new informations. And if you think about the last one that we talk about, the observer is almost the same. It's not the same, but let's see. At first sight, decorator might look similar to observer because both allow us to add more actions without changing the original classes. But there is the key difference. Observers is about to broadcasting events to many listeners. One object notifies multiple observers, each react independently. Decorator is about layering extra responsibilities around a single object. It's still one to one, but enriched with additional behaviors. So the observer reacts to events while decorator extend behaviors. Uh, I think real samples in .NET could be, we can see that in HTTP client handlers. Each handler wraps the next one, adding logging, retries, authentication, or headers. That's decorator patterns in production. And why it matters? The key advantages are stand behaviors without changing existing codes, avoid subclasses explosion, add or remove features at runtime, and keep classes single purpose, following clean code principles. In a nutshell, the decorator patterns let us add responsibilities to an object dynamically by wrapping it. It's flexible, modular, and clean alternative to deep inheritance trees. Uh, that's the decorator pattern. So I think in the next video we will continue exploring the design patterns that help us to write scalable and maintainable software in .NET. And that's it. See you next time, right, guys?